So, good morning. Myself B. Kashinath, working as senior lecturer in Government Polytechnic Sangareddy in Electronics and Communication Engineering Department. Presently, I am going to teach the subject of electronic measuring instruments, that is in third year, fifth semester, and the subject code is, and it comes under the elective subject, elective A. Subject code is and it is comes under the C18 curriculum, so 18EC504 elective A. And the topic I am going to discuss is today the third chapter in electronic measuring instruments. So that is the digital instruments. So in that one, first topic of in this digital instruments is, so what is digital instruments and what are the advantages of digital instruments over the analog instruments. So on completion of this period, you will be able to know about the digital instrument and what are the advantages of digital instruments over the analog instruments, and what are the basic building blocks for the digital instruments to convert the analog input into the digital output. So basic building blocks are analog to digital converter, signal processing unit, and finally a display unit. So mainly why we are going for digital instruments means these are replacing all the analog instruments in laboratory work. In laboratory environment, we are going to check various parameters in educational or research or anywhere in the engineering applications, where we have to measure the parameters like voltage, power, frequency, or some logic levels. For that one, what happens is, when we are measuring with the analog systems, so in analog instruments we will be having a pointer on the continuous scale, so which will deflect according to the measurements. So whenever we are measuring using the analog, so basically, previously all the instruments are analog in nature only. Instruments are also analog in nature. We are measuring with the analog instruments only. In that one, what happens is, we are measuring with the analog instruments. In that one, we will be having a pointer pointing on a continuous scale, and on the continuous scale we have to check the result of our measurement. So that will be uh, tricky. That will be tricky, and it will be overlooked by users sometimes. Means if you are seeing at one time, means if you are seeing it like, suppose I am see now the time is 12, I am seeing the reading like 5 volts. At 12 5 seconds, the reading will change to 5.2 volts. But we cannot discriminate between the 5 and 5.2 because the scale is continuous scale, and we cannot discriminate between those continuous values in the pointer scale, which is denoted by the pointer. So that's why it is better to go for the digital instruments, which measures these voltage, power, frequency parameters. So whatever the information presents is totally it is analog in nature, that we have to convert into digital form. So digital instruments basically consists of the analog to digital converter, and you will be having the signal processing that will process the digital signal which is converted from the analog, and that processed signal will be displayed on the digital readout, that may be LED or LCD display. So what happens is, what is digital instrument? It displays the values of all the electrical parameters like your voltage, current, frequency, or some logic levels as Discrete numerals means we will be having the display of LED or LCD. On that we are directly seeing the numbers instead of pointer deflection on a continuous scale. So in analog instruments we will be having a pointer which is deflecting on a continuous scale. So that is the case of analog instruments, but in case of digital it directly displays the electrical parameters as discrete numerals instead of the pointer deflecting on a continuous scale as in analog instruments. So basic advantages of these digital instruments over the analog instruments is it reduces the human reading and interpolation errors. So first advantage of digital instruments over analog instruments is it reduces the human reading and interpolation errors. So human reading will be accurate and interpolation means, so that is what I have said, that if you are seeing at one point of time and the next point of time in analog it may change, but we cannot discriminate. But in case of digital it can we can directly read out the whatever the discrete numerals that are present on the LED LCD display. So no problem of that interpolation errors will be there in case of the digital instruments. And it eliminates the parallax error, and it increases the reading speed. So by using this digital readout displays, reading speed also increases. So analog indicator, it will take some time to read the accurate value of the reading, but in case of this digital instruments, reading speed will be increased and accuracy also increased. High accuracy up to how much? Plus or minus 0.003% means the value which you are reading is, if suppose the value you are reading is 10 volts, it can be changed from miniaturely from 9.997 to 10.003%, like that. So very much high accuracy can be obtained by the digital instruments. So it possesses the good reliability and repeatability. So reliability also major concern means in different operating conditions and after some aging also, reliability of these digital instruments will be more compared to the analog instruments, whereas analog instruments after some days it will deteriorate, performance of the instruments will be deteriorated, and repeatability will be also good in case of digital instruments. Means if you are measuring at one day the reading, after some 10 days if you are measuring the same reading, in case of analog the reading will not be accurate, means it will not same. But in case of repetition of, in case of digital instruments, repetition also it possesses the good repeatability, no problem in changing in variation of the measured requirements. So output is available in digital form, which will be used for further processing, and it can be used for recording and remote transmission also. So that is the one more basic advantage of the digital instruments. And high input range, that can be from plus or minus 1.60 to 1000.000 volts up. So it can have various inputs from plus or minus 1 volts, having 6 zeros to the after the decimal point, to the 1000 volts having 3 zeros to the after the decimal point. It can have that much input range can be having in the digital instruments. But in case of analog instrument, this much input range we cannot observe in case of the analog instruments. Very low power consumption as in the case of digital instruments, which will consume low power, and wide range of frequency response and measurements. We can have wide range of frequency response and measurements, and high sensitivity will be high, and no loading effect due to high impedance. So digital instruments will process high impedance, so that no loading effect will be less, and accuracy will be high, resolution is better. You can have reading speed is very high due to the digital speed. Output is in the digital form, that can be directly recorded and is suitable for further processing. So still, due to small size and digital instruments are portable also, and small size also, and we can develop the IC chips so that the cost and size and power requirement of the digital instruments are drastically reduced. These are the various uh, advantages of the digital instruments over the analog instruments. So we will discuss again. So what are the advantages before going to the basic building blocks of the digital instruments? So due to the digital display, the human reading errors and interpolation errors and parallax errors are reduced, and they are having high accuracy, and the resolution is very much high. They have high input range with automatic range selection and the overload indication. This is also the one of the most advantage of the digital instruments, which is having high input range with automatic range selection and overload indication. And the resolution and accuracy is high and resolution is better, and input impedance is high, so that no loading effect occurs on the digital instruments, and the reading speed is very high due to the digital display, and the output is in digital form and can be directly recorded, and it is suitable for further processing also. And it is these digital instruments are small size and portable, and with the development of ICs, the cost, size and power requirements are drastically reduced. And now coming to the building blocks of the digital instruments. So whatever the data that is there from the real world, it is analog data that has to be converted into digital data by using the analog to digital converter. By using the A to D converter, we are converting the whatever the real world data, that may be frequency, voltage, current, pressure, temperature, humidity, everything will be continuous in nature, that is in analog in nature in the real world, that has to be converted into digital by using of analog to digital converter. So after converting that, we are processing the signal, and finally we are giving the output to the display unit. So you can draw this diagram, or you can take the screenshot of this one, basic building blocks of the digital instruments. So we will discuss about each of this block. So yeah, anyway, input signal is analog in nature, that is continuous signal coming from different real world signals such as temperature or current or voltage from the different instruments, or pressure or humidity from the environment that we are going to measure. So that has to be converted by the analog to digital converters. So particularly digital voltmeters or multimeters are used to measure the analog quantities. It is necessary to convert the analog signal to an equivalent digital signal by the analog to digital converter. So A to D converters are used in as main elements of the digital instruments. So in digital instruments, A to D converters is the main elements, and the second one is signal processing unit. So it is a microprocessor for processing the digital signals. So your computer will process these digital signals. So in case of nowadays everything is microcontroller. In the previous cases, we are using the microprocessors that will process this digital signals coming from the analog to digital converter. So that is digital decoders and drivers are used to interface digital output from the analog to digital converter to the display unit. So whatever the signal coming from the analog to digital converter, that is very low strength value signal, so that has to be amplified, and it is given to the drivers, and decoders will decode the digital data, and that will be given to the display unit through the drivers. The drivers will drive the different digital display units, and whatever that A to D converters output will be given to the display unit by this signal processing unit. So we will be having in signal processing unit microprocessors which will decode the signal and drives to the display. So display unit, digital meters use numeric LED displays or LCD for showing the reading of the measured quantity. So LED means light emitting diode display, or LCD means liquid crystal display. You can have two types of displays for your digital instruments. So digital meters use numeric. So it is numeric display having either LED display or LCD display for showing the reading of the measured quantity. Both LED and LCD displays are in 7 segment format. So already you have studied about the 7 segment format in second year digital electronics. So 7 segment consists of the you have already studied BCD to 7 segment display. So 7 segment display, each number will be display indicated by the 7 segment display corresponding to different cathode anode arrangement. So it is like this. So basic display, numbers display will be like this. So upon 7 segment display means totally you will be having the 7 segments. So that 7 segments completely on in the case of this number 8. So the number is divided into total 7 segments. So each divided crossed lines so will be having one segment. Totally you will be having the 7 segments. If all the LEDs on or by decoders, then you will be getting this number 8. So based on different LEDs, different segments on and off by the decoding signals, BCD to 7 segment display, BCD to 7 segment. So in that case we are getting different numbers on the display by switching on and off of the different segment. Suppose if you are this middle one is off, then you are getting the 0, like that. If all the segments are on, you will be getting the 8 number. If only one of the segment is off of this one, then you are getting the number 9, like that. You will be having the different display according to the BCD to 7 segment display. So each digit in the display has 7 separate segments. As I already told, each digit in the display has 7 separate segments, and numbers are formed by activating the appropriate segment that highlights the number. So this you have to remember. So each digit in the display has 7 separate segments. Totally 7 separate segments will be there, and each numbers are formed by activating the appropriate segments that highlights the number. So I have already told, if all the 8 segments, 7 segments will be on, then you are getting the number 8, like that. This you can take the screenshot or you can write down. So in the today's class we have discussed about what is digital instruments and advantages of digital instruments over the analog instruments, and what are the basic building blocks of the digital instruments. So what is digital instruments? So digital instrument is an instrument which will convert the whatever the real world analog signals that are converted into discrete digital readout form. So for that one we are converting the signal, analog signal into digital signal by the analog to digital converter, that will be processed, that is decoded and driven to the display unit by the signal processing unit, and finally we are displaying the digital readout on the LED or LCD display of, it is mostly of the 7 segment type. So in 7 segment type, based on different numbers, we are on or off of the different segments, so that different numbers will be displayed on the LED or LCD screen. LED means light emitting diode, LCD means liquid crystal display. And advantages of digital instruments: if it is asked for 3 marks, you have to write at least 6. If it is asked for at least 1 mark, you have to write at least two advantages. And the advantages are uh, accuracy is high, resolution is better, input impedance high is high, so there is no loading effect, and the reading speed is very high due to the digital display, and the output is in digital form, can be directly recorded, and it is suitable for further processing. And due to this digital display, human reading errors, parallax errors, interpolation errors will be reduced, and it will be having very high input range with automatic range selection and overload indication. And the cost and size will be less, so it can be portable, means it can be moved from one place to another place, like that. And it is has better reliability and repeatabilities. So these are the various advantages of the digital instruments compared to the analog instruments. A simple quiz on this topic. So the digital instruments are those which use, so first option, use LED or LCD for display, use deflection type meter movement, have numerical readout, both A and C. So it can have either LED or LCD display, have numerical readout. So the option is both A and C. Both A and C is the answer for this question. And the frequently asked questions in this topic is: list the advantages of digital instruments over analog instruments, and draw the basic block diagram of digital instrument and explain its working. You have to draw the block diagram, that is input analog data, analog to digital converter, signal processing unit, output display, and you have to explain each block. If it is asked for 3 marks, you have to draw the diagram and you have to explain each one. If it is asked for 1 mark, then you have to just draw the block diagram, that is enough. And the advantage also, if it is asked for 1 mark, you have to write at least 2 advantages. If it is asked for 3 marks, you have to write at least 6 advantages of the digital DAs over analog instruments. So this completes the first topic in the third chapter of the digital instruments, that is the advantages of digital instruments over the analog instruments. Thank you very much.